Hello, welcome to AP Biology with Mr. Rickard. Today, we're going to talk about topic number 1, the emergent properties of water. So here I have some distilled water for us to play with. And right now, I'm going to take a piece of paper towel and put it inside for reasons that will become apparent later. So let's just leave that for now. Okay, so welcome to my classroom. I hope that we have a lot of fun today learning about the properties of water. So let's start with a quick quiz. So let's look at this slide together. Imagine with me if we were to zoom in onto the molecules of this pure distilled water, what would it look like? Now, go ahead and put on your chemistry hats and try to think back of everything you learned. What looked like this first group of molecules? Would they all be orientated kind of like this group? Would they be moving around randomly like group 2? Or would they be orientated like group 3? Go ahead and pause the video and take your best guess. Okay, hopefully you said they're going to look like group 3. Why is that? Well, the answer is hydrogen bonding, but let's get into it together. So first, if you said group 2, that's a good guess. Probably you remembered from chemistry that some molecules float around randomly in space and they're able to, they're gonna have a variety of different configurations. This is actually absolutely true for water vapor. However, we're not talking about water vapor, we're talking about liquid water. If you said group 1, that's also a reasonable guess, looks organized, but actually group 3 is the correct answer because of the unique polarity of water. Water is an extremely polar molecule. Let me tell you what I mean by that. I'm going to get rid of this. So water, as you all know by this point, is comprised with an oxygen, which I made blue, 2 polar covalent bonds, which are black here, which connect the oxygen to 2 hydrogens. Now, because of the electronegativities of oxygen and hydrogen, meaning oxygen is a much bigger, stronger element that has more protons than hydrogen. So it's going to bully these polar hydrogens, even though it's a covalent bond, meaning there's sharing going on. There's also, it's not a balanced share. It's not like oxygen gas, which has 2 oxygens together and it's completely balanced. However, in this one, we have a polar bond. The oxygen is going to be a little bit, we call it electronegative. And we would write that as a delta minus. It has extra electrons, and those electrons are giving it a negative charge. It's kind of like the Lakers right now. They have extra players like Russell Westbrook that they don't need, and they're bringing the team down because electrons are negatively charged. Hopefully you like that joke. Okay, if we have all the electrons or the electrons that are shared being pulled toward the oxygen, that means this hydrogen and this hydrogen are going to be what we call electropositive. They're lacking electrons. They're in a positive chemical state. Because of this partial negative charge and partial positive charge, which again we would write as delta, the Greek letter minus and delta plus, all of these waters are going to be interacting. We call this unique type of interaction hydrogen bonding. Now, what happens with the hydrogen bond? I erased one of my hydrogens, but we'll use these 2. What happens with hydrogen bond is this hydrogen is able to interact with adjacent oxygen. This hydrogen would be able to interact with another oxygen somewhere else. This is kind of a two-dimensional, drawing, so it's a little hard to show that. But each of these hydrogens, because they have a positive charge, are going to be interacting with the negatively charged oxygens. This oxygen will also be able to interact with 2 hydrogens, meaning that each of these molecules will have a hydrogen bond with 4 other water molecules. Pretty cool. Now, what's interesting about this is that unlike these covalent bonds, which are permanent, strong bonds, that keep the molecule together. These hydrogen bonds, even though they are relatively strong dipole-dipole bonds, because of the polarity of the water molecules, even though they're strong bonds, they're very temporary, meaning all the oxygens are constantly rearranging themselves. So all this leads to some very interesting emergent properties of water. So let's get into what this actually means, why this matters. So in terms of biology, why this matters is the unique polarity of water leads to 4, and 2 of these are linked. So in the textbook, it says 4. I'm going to give you 5 emergent properties of water. Number 1, cohesion. And this one is the least surprising. When we say emergent, by the way, what we mean is that just by looking at a single water molecule, you could say it's polar, but you wouldn't be able to predict these properties just by looking at one. You have to understand how they're gonna interact all together in a macro perspective. So number 1, cohesion, and this one is the least surprising, is that if you have all these molecules all interacting with each other, the positive hydrogens are interacting with the negative oxygens, which are interacting with, and the negative oxygens are interacting with positive hydrogens of adjacent water molecules. And we have constant bonding or temporary bonding between these water molecules. It's going to lead to cohesion. That's going to create a layer, because the waters are all attracted to each other, that separates the water from most external environments. And that's called surface tension. That becomes important for a lot of life and is related to the cohesion of it. Next, the water molecules are adhesive, meaning that they are attracted to other polar molecules. For example, if you look here, the water has been slowly working up this paper towel. Given enough time, it would actually work its way all the way up the paper towel and out of the beaker, but this is a short video, so we won't wait for that together. And I messed that up. That's called capillary action. The water is attracted to the paper, just like water is attracted to the wood of a tree, and it goes all the way up the tree. The next property of water is its high heat capacity. This is important because it means that water is going to store the heat during the day, and it's going to release it during the night. So during the day, if you live near the ocean, you know, it's pretty nice. There's a nice ocean breeze usually. That ocean breeze is because the water is storing, is cooler than the air during the day, and it's actually warmer than the air often at night, depending on ocean currents and all that. So water has a high heat capacity. Number 4, water used to be called the universal solvent. Now that it kind of got canceled for this title because it's obviously not going to be a solvent or dissolve everything. However, how it got its name in the first place is because these interactions, hydrogen bonds, can also interact with other molecules. For example, if we put salt into here, those ions will dissolve into the water and form what we call an ion dipole intermolecular interaction. And so water turns out to be uniquely good at dissolving. And so that's why it was called the universal solvent. For biology purposes, water really is the universal solvent. All of life is designed to interact with water, and we're going to categorize chemicals as either being hydrophilic, that is, they're attracted to water, or hydrophobic. And both of those assume water is the background. And lastly, because of the unique structure of water, a last emergent property of water is that ice actually floats. Everything else we think of solids generally being heavy and liquids as generally being lighter than them. However, for the same chemical water, ice is actually lighter than liquid water. What this means is that lakes will not freeze during the winter all the way. They're freeze on the top, there still be a habitable zone for water. And so that becomes very important for aquatic ecosystems. Okay, I hope that helps. Again, these cohesion and adhesion both have to do with the dipole interactions of water, so those get lumped together often, but these are the 4 or 5 emergent properties of water that you need to know for this class. Hope you had some fun. Sorry, Lakers fans for roasting Russell Westbrook, but it needed to happen, and I hope everyone's doing well. Have a good day.